This lecture is about time. We're going to talk about how to visualize time in your geovisualization. And this lecture is based on 3 papers. You can also divide this lecture into 3 parts based on these 3 papers. The first part is about the born of time geography. Okay, and the second one is about the development um, from the time when the time geography was born and today, what happened during that time period. The third part, we're going to talk about a new form of GIS. It's called space-time GIS. Although it's something we expect, but you will see that there will be a lot of difficulties, even given today's powerful software and hardware. For now, space-time geography is just, you can say, um, a dream. A dream is just too far away. Maybe something we can implement in near future, but not right now. Okay, let's get started. So first paper here is called What About People in Regional Science? It was published by Professor Hagerstrand in 1970. It is considered as the beginning of time geography, but this paper uh, was not supposed to invent something called time geography. It was about regional science. So regional science is science concerned with analytical approaches to problems that are specifically uh, urban, rural, or regional. And is concerned with the fate of the individual human being in an increasingly complicated environment, or if one prefers, questions as to the quality of life. So you can say it has nothing to do with geography, okay, this paper. And according to Hagerstrand, in this paper, I quote, with a concern for the individual, it follows that we need to understand better what it means for a location to have not only space coordinates, but also time coordinates. Because he wanted to talk about the quality of people's life. So people's life is pretty important, and a people's life, any people's life is related to not only space, but time. So there must be some method to address time when he's trying to talk about people's life. And in time space, okay, time space is a concept of obviously combining time and space, right? This concept is used by Hagerstrand to address people's life. Okay, the individual describes a path. In time space, the individual describes a path starting at the point of birth and ending at the point of death. And these passes, they are non-random, which is necessary for survival. What does it mean? It means that, at least for now in our society, you do not have the freedom to choose the path you want to go along with. I mean, today we can choose who to be, or you can choose where to go relatively freely compared to maybe 100 or 200 years ago, or in Asian compared to Asian society. But still, you need to work. You need to go to school. You need to receive education. So you can earn money. You can make sure that you have food. You can create a family maybe, but it's non-random. It's non-random. You have to follow this uh, created path and the conventions, right? It's non-random for your survival, And this life path became captured within a net of constraints. Since you do not have the complete freedom, there must be constraints. Okay, it seems to be more promising to try to define the time-space mechanics of constraints, which determine how the paths are channeled or dammed up. Some authors believe that the study of negative determinants might be the safest kind of social science. So in this paper, Hagerstrand tried to summarize the constraints we have in our life and use them to address people's quality of life. Okay. One more thing I want to mention here is that the three papers, they are not GIS technique papers. They're more like human geography papers we're going to talk about in this lecture. So you will see a lot of quotes. And these human geographers, they're trying to use a lot of philosophies to provide some guide to what? To different types of geography and to propose different methods. So human geography papers, they're very different from GIS papers. Okay, so there will be a lot of stories and quotes. Okay, so it's different. And let's talk about constraints proposed by Hagerstrand. Okay, constraints may be characterized in terms of location in space, areal extension, duration in time. Okay, and there are three types of them. Capability constraints, that's the first type. Second type, coupling constraints. Constraints existing between people or among people, between two people or among even more people. And authority constraints. Let's just go through them one by one. So capability constraints are those which limit the activities of the individual because of his biological construction and or the tools he can command. So there are three circles that can define capability constraints. The first circle is the smallest one. It's called inner circle. Arm's reach. Okay, that's the smallest circle of capability constraints. The second circle is called outer circle, sight and voice reach. The third one is called extended circle, reach where traveling. So walking, driving, or today, flying. Flying is very different. Flying is very different. But no matter what, there exists a definite boundary line beyond which he cannot go if he has to return before a deadline. Okay, so here everybody has to exist spatially on an island. Of course, the exercise of the island depends on the available means of transportation, but this does not alter the principle. What does this paragraph mean? It means that we can define an island that everybody lives on. The center of this island is your home, right? And no matter where you go for a single day, eventually you are going back home. That's your normal life, right? But if you can only walk, your island is pretty small because you need to walk to a place and get back within 24 hours. But if you can drive, the island is larger. If you can fly to other areas, you can consider that you can fly from your single island to another island, maybe another city or even another country, and get back within 24 hours. So that's the reason why transportation here is pretty important. Advanced transportation methods, for example, driving or flying, they are what? They are making the extended circle even larger, and especially flying. For the flyer, the entity has been broken up into an archipelago of smaller islands around the airports, which are within reach. While in the air, he is imprisoned in a narrow space-time tube. Here, for flying specifically, this tube is the airplane you are taking, right? Without opening, and he does not therefore effectively exist in the geographic locations over which he is flying. What does it mean? It means that you are living in US, right? So you can consider you are living in Columbus, is that your living on this small island called Columbus, Ohio. And today, there is a plane to another country, say to Mexico. You can take that plane to go to Mexico, and you can consider Mexico as another island, okay? Or any other place or country, you can go there. And when you are flying, you are imprisoned in your what? Airplane, right? And you cannot just jump off the airplane during the traveling, right? Because it's in the sky. And although, maybe, for example, you are flying from Columbus to Beijing, you will travel over the Pacific Ocean. Okay, although you are flying over the Pacific Ocean, do you actually exist over the Pacific Ocean? Or say you're flying to China, right? You will fly over Hawaii. Can you say that you've been in Hawaii after this round trip to China? You cannot say that. Although you flew over Hawaii, but you cannot jump off. You did not exist in Hawaii, in that geographic location. So that's a special part about airplane. It's a time-space tube. It's a closed one. It's a closed one. Okay, so the concept of extended circle is more complex because it's related to our transportation methods. And here one concept you should be careful is that we're living on an island. You can consider 1 day as your deadline. Okay, let's just use 1 day as a limit, as a unit of time geography. Okay, 1 day. And if we look closer at the time-space volume within reach, it turns out to be not a cylinder, but a prism, okay? It not only has a geographical boundary, it has time-space walls on all sides, okay? So here is the method proposed by Higgelstrand to address time, not only in geography, because at the very beginning, it was proposed to use in regional geography, okay? So here, let's say we have three space-time prism here. And one is for walker, another one is for driver, the third one is for flyer. Let's focus on the one for walker first. If you know what it means, you will know what those mean, what the rest two mean, okay? So we have two axes here. The first one is the horizontal one. It is used to address distance. And the vertical one is used to address time. And like I mentioned before, this time is always 1 day. So at the at the origin of this coordinate system, it is, you can consider it as the midnight of a day, right? And at the end of this vertical axis is the midnight of the next, it's 24 hours later. Let's say that, the next midnight, right? Okay, what does it mean? It means that, okay, from the midnight, usually, if it is midnight, people are in bed, right? You are in bed, this walker is in bed, sleep, right? And after some time, along this vertical axis, after some time, in the morning, maybe 6 o'clock, he or she wakes up and walk to a specific place. That's the reason why the position of this walker changed horizontally, because horizontal axis is for distance. He or she walks to a place, and when she or he gets there, he or she turn back to home immediately and use some time to get back home and move back home here during the night. Maybe 6 or 5 in the afternoon, okay? And stay home for the rest of the day until the midnight. And the next day is the same thing, right? Stay home and sleep and go to that place again and get back home and sleep. You should know that when he or she get that specific place, which is a corner of this prism, he or she did not stay there. He or she turned around immediately because at that specific location, there is no change of time. It's a point instead of a what? Instead of a vertical line, right? There is no time change at that location. So here is 1 day of a walker. So here we have a larger prism, space-time prism, because now it's for a driver. Within the same time, obviously, if you're driving, you can go a place further away. And when you get there, you did not stay. You get back home and stay home. For flyer, it's even more complex. We have dash line here. This dash line here represents you're traveling on a plane, on an airplane. You cannot escape it during this traveling process. So it's dashed line. And then when you get to the second place, you go to the third place and you get back to the airport of the second place and you fly back home. Here is the airport of your city and you get back home. Home is actually here, right? And you go to sleep. The second day, this is a weird person. The second day, he wake up or she wakes up and go to airport and fly to the second place airport again. And from that airport, go to another place again, get back to this airport of the second place and fly back to the airport of his or her city and get back home. So this, you can say, it's a very simple but effective model of time. So actually here, you are visualizing time using this simple but powerful tool called space-time prism. So we can have even more complex ones. For example, here, walking walker. Walking walker means that if you when you wake up in the morning, you go to, let's just use this walking driver one. It's easier to explain because it's larger. So you wake up in the morning here, right? You wake up in the morning, you drive to a workplace. You need to stay there for 8 hours. That's why here we have this vertical line, but we don't have it here. We didn't have it here, right? Because you don't have to walk there. You get there and you get back home. Here you have to walk there, to stay there for some time and get back home and go to sleep or stay home until you go to sleep, right? So depending on a specific trajectory of a person, we have different types of prisms. And since we only have 24 hours a day, you can do only limited things within a day, okay? So here, relation between remaining prism and the preceding path. So if, the vertical axis is 24 hours. If you have used some of them, it means that, of course, you can use the rest to do other things, to go to other places, but your prism will be smaller and smaller for the rest of the day because it's 24 hours. The vertical axis has decided that you only have, everybody has 24 hours a day. If you have used some, you can do limited things using the rest of 24 hours, right? Every stay at some station, the station could be a working place, could be a cinema, could be a Kroger, could be a Walmart, right? Anywhere, means that the remaining prism is shrinking in a certain proportion to the length of the stay. Like I said, you only have 24 hours. Okay, that those prisms we have discussed here, I've introduced here, they are for capability constraints, right? And it mostly decided by the time of, sorry, not by the time, by the method of traveling, by the method of transportation. Next type of coupling constraints is called, the next type of constraints is called coupling constraints, okay? Coupling constraints define where, when, and for how long the individual has to join other individuals, tools, and materials in order to produce, consume, and transact. right? I think it's relatively easy to understand because, for example, you are working as a GIS analyst in the future, say that you have to work with a PCA, right? You cannot work without a PCA because a PCA now is the only way you can use to deal with geographic data because these data sets today they are manipulated by a GIS system, and in order to use a GIS system, at least you should have a PCA. So you and this PCA or your office PCA, you are bonded. Okay, you're coupled. Here is an example. It's another version of the space-time prism here. For example, we have a couple, husband and wife. Husband is working at a factory, the wife is working in an office building, in an office. So now we have three-dimensional space-time prism here. It's just for the convenience of addressing different locations. Okay, for example, in the morning, they both wake up, and the husband needs to go to factory, say at before to get to the factory before 8 o'clock. So the left prism here is for the husband. The right prism here is for the wife. Okay, in the morning, the husband drives to the factory, and he is connected with this very thick, straight line. This is the machine. Okay, so he and this machine forms a coupling constraint. He needs to stay with this machine to finish the work. Okay, and the wife does not need to go to the office in the afternoon, but she goes to the office maybe 11 in the morning, or say around the noon, and we have other people also joining this wife to work together in the office. It makes sense, right? And they are having a meeting. From 11 o'clock to 4 o'clock in the afternoon, or 3 o'clock. And some of them, they are leaving. And this prism here, this line here, is also the line for the wife. And 5 o'clock, before the end of the day, this wife and the husband, they are making a telephone call to discuss what to eat and who should pick the kids after the work, right? So within a very short time period, they are bonded. There is a coupling constraint between them, between husband and wife, because they're making a call, okay? And then what? Then they go back home. Maybe he is trying to buy some food from grocery store, and the wife is going to school to pick up kids. And if we show the rest of the picture, they should get together and get back home. Okay, so here is the concept of coupling constraints. It's not about an individual's capability. It's about the bonding between man and machine, or different people. Okay, we may refer to a grouping of several paths as a bundle. Okay, here you can see that this bundle between the husband and the machine, and the bundle between the wife and her colleagues, and the bundle between the husband and the wife. And bundles. There are many predetermined bundles that must be acknowledged and respected. For example, work, school, etc., right? And the telecommunication today allows people to form bundles without loss of time in transportation, okay? Before, telecommunication is a thing. If you want to talk to somebody, you have to get there to talk with him in person, and or write a letter. But today, you can save a lot of time using telecommunication. Okay, so telecommunication is a big advance in saving time, say that, with more efficiency, right? And the third type of constraints is called authority constraint. There are space-time aspect to authority, for example, control areas or domains. The purpose of domains seems to be to protect resources and to form containers which protect an efficient arrangement of bundles. There are permanent authority constraints and temporary authority constraints. For example, if you are going to a movie theater to watch a movie, there is authority constraint. You have to buy a ticket to get into this domain, into this control area, which is the theaters, movie theater, to what? To access resources. This resources here is a movie you want to watch, and this is a temporary constraint. After the movie, you just go home, and that domain is not controlled to you because you don't want it anymore. So a cinema, a movie cinema is a typical domain controlled by, or I'll just say controlled by authority constraint. There is authority constraint because you have to pass this constraint by what? By buying a movie ticket. There are also permanent domains. For example, a country, right? In order to get in a country, you have to apply for a visa first. And I mean, a country could change, could disappear in hundreds of years, but relatively compared to a movie theater, compared to a movie, let's just say it's permanent, okay? So we cannot just bypass authority constraints if you want to go inside a controlled area or domain, because in most cases it's illegal, okay? And there are also interactions among different types of constraints, right? The three aggregations of constraints interact in many ways, in direct, obvious ways, and in indirect ways, which are less easily detectable. And of spatial interest in terms of complicated interactions are the dependent members of families. For example, a child, right? For example, a 5 or 6, say a 7 years ago, a 7 years old boy, he cannot go to school himself. That's capability constraint, right? So he has to form some coupling constraints with his parents so they can use a car to send him to the school. And there is also authority constraints to this child because at home he should listen to his parents, and in the school there is also authority. He needs to listen to his teachers, right? So these three types of constraints, they do not exist independently. Sometimes they exist simultaneously. Not sometimes, most time, in most in most scenarios, they exist simultaneously, and everybody is limited by them. Okay, I'll just stop here. In the next part, I'm going to talk about what happened from between the birth of time geography and today, and what is GIS role in this history of time geography. Thank you.